Okay, Module 4, Part 2. We're still in the development strategies. And now we are talking about packaging of machine learning model. Now comes to the packaging of the machine learning inside the application, the whole software package, the whole software application. So in order to put the model in production, first of all, we have to think about the model like it's a piece of code. And finally, this piece of code, always we have to ask ourselves, where do we put this code and how? So one of the things is that we have to package actually this model. How to package this? There are different ways to packaging it. So packaging methods depends on the condition of the system actually. So the first thing is that we serialize it. Serialization means that converting the machine learning model to a format for storage. So it should be lightweight, but not very complex. So for the complex things, we have other methods. Also, when we have the model, we have to package the environment. So this is the environment packaging. Why we do this? Because we want to make sure that the environment is consistent, the model is consistent with the environment, and the model is running in the same environment that we compiled. So this will reduce the compatibility problems, compatibility issues. Finally, we have containerization, which package the model, dependencies, and environment together all and run in a container. And this is very important because it will reduce a lot of compatibility and packaging problems. However, it needs some kind of expertise in the containerization and deployment. Now, let's talk about the packaging format options. We have different format options. However, it depends on the development framework and that which kind of format it can produce, and also the model format that you can serve in which framework. So both these two things, which kind of environment you have and which kind of development framework you have, these together will identify which one you can use. We can save the model in different formats, in various formats. Some of the formats that available is, one of the thing is this PMML, which is productive model markup language. There are pros and cons for each kind of packaging, of course, each kind of format. For example, this PMML is universal, is a kind of used widely, train a model using one programming language, but then you can load it and serve it using an application with a compatible in a completely different one. There are cons also, difficult to customize. This is one thing. And we have another thing which is widely used, which is the pickle. Pickle is used within Python, is not specifically used for machine learning, can be used for any other things with Python. That's the good thing. The other thing is that no cross-platform compatibility, training and serving environment must be identical. So it's more tied to Python actually. But in any case, there are many other things also. You can, many other formats. Let's look at, for example, serialization in Python, how we do this. This can be loaded into the memory and used for prediction or scoring or whatever. Most of them are used through scikit-learn. These models can be easily serialized when you are in scikit-learn. For example, you import for the pickle in the left-hand side, you import the pickle package, let's say API, and then first of all you have the model. You do whatever you want with the model until you get a good model, as the customer want, as you want, doesn't matter. And then you serialize the model to a file. So you open the model.pickle and then you serialize it with dump. If you want to load it, it's just like you'd load the model that you created. It's so easy. Also, you have HDF5 you can use. Also, it's another way of serializing. Again, you have the model and then you serialize the model to HDF5 file, which is another format, of course. And then you load it. Basically, when you have it, when you want to load it, you just load the same file that you dump. So it's also so easy to serialize. Also, PyTorch and TensorFlow, when you create the model, you can immediately in Python serialize them. So basically, first of all, in PyTorch, you train the PyTorch model, and then you store it basically with a name. You say this is the model, and then you serialize it. So you can see that it's the same concept in all formats, but it's a different of syntax only. So then you serialize the trained model. You have the model in PyTorch, which is the trained model in the left-hand side, and then you just serialize it. If you want to load it, you have a syntax to just dot load. The same way for TensorFlow. You have the model, you create the model with the TensorFlow, you train it, and then finally you are happy with the model. And then when you are happy with the model, you just serialize it by saving the trained model to a directory. Then when you want to load it, you just load the saved model. Machine learning environment packaging in Docker. I'm sure most of you know Docker, and Docker is very important for packaging and for the whole environment packaging. Why we do this? Because we want to make sure that the environment is consistent, reproducible, with the model execution and so on. There are a virtual environment that can be used. For example, virtual environment with Conda or virtual inf. You just create an isolated, reproducible environment for machine learning model. You make sure that model is consistent regardless of the system or dependencies. Docker, self-containing unit for easy deployment in any environment. And when you have the Docker file, you just containerize it and you just use it within any environment. Using a Docker file is easy also. Creating a Docker file, containerizing it is easy also. First of all, you use the image of Python, for example, which image you want to use, and then set the working directory. You have the requirement file for all the packages you use. Then you install the requirement file and then set the entry point to run the model. That's the thing. You copy the model into the dependencies into this image. You create the image and then you set the entry point. Within this entry point, you can call the the Docker file. So you can see that we have a workflow for using Docker. First of all, you have the model, you serialize the model with the format that's suitable for you. For example, Pickle, HDF5, or PyTorch. All the steps that we used before. And then second, when you have the serialized model, now you containerize it with all dependencies and environment. When you have the model inside the container with all dependencies and environment, now it's time to deploy the Docker image into a target environment, for example, into the cloud. Then you run the Docker. When you run it, you have the entry point. You call this entry point through an API, and then that's the use of the model. So now you have the machine learning model, the AI model that can be used in cloud, in edge, in any containerized environment. So when you have it and you deploy it, everything is okay. But before that, you have to test. You have to test a lot. So classically, when you have a product, you can use several routines of testing. Three essential classical testing is that unit testing, integration testing, and smoke testing. These are the concepts, the three classical routines that you use. So unit testing, I'm sure you know this, for the software, for normal software, not machine learning, but machine learning also, we have the same concept. Unit testing, we individually test each component in isolation to make sure that every component is working as it is. When you have every component is working, then you integrate the components together inside the machine learning program, and you make sure that you create the pipeline, and then you make sure that all the components together working correctly. And when you have everything in place and everything is working, then you have the smoke test, which is the quickly test the system. We will come back to this smoke test later. Next slide. And there is very good practice to know, which is the test early and test often. Test the model on new data as soon as it become available. Example of unit testing, how to do the unit testing, generate mock data for the testing. That's the thing. You have the model, you have everything in place. Now you want to test it, you create a function for unit testing. And then when you create the function for the unit testing, you just generate the mock data, fit the pipeline on training data, and evaluate it on the testing data as usual. When you have the assert also, you assert the accuracy, for example, more than 80%. When you have the assert with the accuracy greater than this unit testing can be run as part of the target of a larger test suite, of course. Integration testing, we want to make sure, as I said, that all the components after unit testing, all the units are working together, for example, the functions. However, this can be done inside a staging environment. What is a staging environment? Staging environment is a copy of the production environment, a small copy of the small working version of the production environment, which is called the staging. So it mimics the production environment, basically. You have the development, you test everything on the staging because you cannot do the integration without an environment to integrate everything. So if that is the case, we want to have a staging. So staging means that you have the API, you have the database and everything in place, or you have a small version of this that can simulate the production environment. So in order to do this integration testing, we need environment matching. That can be done through this staging that we said, which is replicating the production environment closely as possible. And the data in staging and the database should contain data that mimics the production data set. Although it can be smaller, but still it mimics. And the ideal case is that if you test test everything on staging, it should be like a copy paste to the production, no change or very, very little change. Finally, we have smoke testing, load testing, and stress testing. Smoke testing is a slightly different from load testing and stress testing. Smoke testing, for example, to check if the application can be deployed without critical errors, without crash and burn, for example. However, the load testing to assess that the application perform under expected user load conditions. So the load testing, for example, if you expect like there will be 1,000 or maximum 2,000 call for my application request, for example, inference for my application. So I have to test the application under 2,000, not more. When it become more, it will be stress test. So the load testing, stress testing is actually load testing, but +1, let's say. It's a load testing plus. So the load testing, we want to test the limit, the upper limit, but not more than the limit. But the stress testing is more than the limit to know how it works.